Today we're going to take notes on section 4.4, which is on writing a function rule. We're going to focus on 3 mathematical practices. Model with mathematics, look for and make use of structure, and look for and express regularity in repeated reasoning. Basically, you're going to be looking for patterns, and then you're going to be writing rules, in other words, structures, to model those patterns. The objective of this lesson is given a function written in a table, write a function rule to explain the relationship. So we're going to go through 4 examples to accomplish this objective. The first example, we have x and f of x. Remember, x is our input and f of x is our output. And we're going to look at the relationship from x to f of x. So here we have 2 being plotted to 8, 4 going to 10, 6 going to 12, and 8 going to 14. So here, the relationship between my x and my y, I could say it's times 4. 2 times 4 gives me 8, or 2 plus 6 would give me 8. Here, 4 times 4 would not give me 10, so that wouldn't stick with that relationship. But 4 plus 6 does give me 10. 6 plus 6 does give me 12. And 8 plus 6 does give me 14. So I notice that the relationship from x to f of x is taking my x and adding 6 to get my f of x. And that becomes my function rule. I'm going to take x and I'm going to add 6 of it to get f of x. So we're going through and we're looking for patterns. Come over to this side and we'll try the same thing. -2 to -6. -1 goes to -5. 0 goes to -4, and 1 goes to -3. So my inputs are here, my outputs are here. Sometimes it also helps for me to see what's happening as I go down. For instance, as I move down the table, that would be adding 1. Move down the table, I'm adding 1. Move down the table, I'm adding 1. Over here, as I move down the table from -6 to -5, I'd be adding 1. From -5 to -4, I'd be adding 1. -4 to -3, I'm adding 1. So I see a similar thing happening here, whereas over here it was adding 2 as I went down, adding 2 as I went down. And this idea here is going to come in more later. I'm going to come back and touch base on that. But I notice both of them are going down through my table at the same rate. So now let's see. -2 to -6. -2 times 3 would give me -6. But -1 times 3 doesn't give me -5. So that one's not going to work. -2 to -6. -2 minus 4 would give me -6. -1 minus 4 gives me -5. 0 minus 4 is -4. And 1 minus 4 would be -3. So it looks like that subtracting of 4 is going to work here. So I get my y by taking x and subtracting 4. I'm going to come over here. I'm going to look for a pattern here and then try to write a rule from that pattern. Right away, I'm seeing over here that I'm going down by 1. But over here, this is going down by 4, down by 4, and down by 4. So that's something different than what's happened on the other ones. So I might see a different type of rule. Notice how this one was just x plus 6, this was x minus 4, very similar rules. Now this one I have something different happening, so let's see what happens with those rules. -1 is going to -4, -2 to -8, -3 to -12, and -4 to -16. You might start to notice all these numbers here are multiples of 4. So let's see what happens if I multiply by 4. -1 times 4 is -4. -2 times -4, or sorry, -2 times 4 is -8. -3 times 4 is -12, and -4 times 4 is -16. So in this case, to get my g of x, I'm taking x and I'm multiplying times 4. And in algebra, we write that as 4x. So notice this one became a multiplication happening, whereas this was an addition or a subtraction happening. And then over on this side, again, looking at what's happening, I noticed right away as I go down, I'm increasing by 1. And over here, 2 to 5, that's an increase of 3. 5 to 10, that's an increase of 5. And 10 to 17, that's an increase of 7. So now that's completely different from what I've seen happening. So I'm going to probably, again, have a different rule. This one seems more complicated, so I'm guessing my rule might be more complicated as well. Going from 1 to 2, x goes from 1 to 2. There's lots of ways I can go from 1 to 2, so I'm going to keep going and look at others. 2 to 5. That could be adding 3, but I know that that's not what's happening here. Multiplying, that's nothing easy to multiply by for any of those. 3 to 10. 4 to 17. Okay, this one takes a little extra thought and a little more knowledge of your numbers. But I know that 2 is 1 plus 1 to get 2. I know that 5 is 4 plus 1 to give me 5. 10 is 9 plus 1 to get 10. And 17 is 16 plus 1, giving me 17. Now hopefully you recognize these numbers as perfect squares. That's 1 squared, 2 squared, 3 squared, and 4 squared. So in other words, to get my y, I took my x and squared it, and then added 1 to that number. Now I know that one took a little bit more of reading into that pattern, but hopefully you see it in the end. So I want you guys to take what we just went over with this, and I'm hoping you took notes while we went through it. And I want you to go onto your student daily agenda on Canvas. And when you're on there, I want you to watch the con videos. There's a con video that's on arithmetic sequences. And the arithmetic sequences, you're going to find a lot of these types of patterns happening. And there's a general formula you use for those types of patterns. So I want you to look through and watch those videos, take notes on that, and then you're going to complete the worksheet that your sub is going to hand out to you. If you have any questions, please come see me tomorrow during tutorial.